It's hurtling towards Venus at 18,000 miles an hour. The plan is to trigger an engine burn to slow it down enough to go into orbit around the planet. Then it'll spend 2 years sending back images and data to Earth.
Venus is our closest planetary neighbour, but it's utterly different from Earth. It's a kind of evil twin with an atmosphere that's hot, dense and corrosive.
Why it's ended up so different is a mystery, one that Venus Express will help to solve. Welcome to Stardate.
Yesterday was particularly tense for the flight engineering team. It was only the second time that they'd attempted to put a spacecraft into orbit around another planet. One of the scientists praying for a good burn is Professor Fred Taylor from Oxford University. Now, Fred, you're obviously a little bit pressed today, but tell me, why is it called Venus Express?
It's called Venus Express because it was put together very quickly at a very low cost, so it's a fast mission.
And Fred, what's the main purpose of this mission?
The main purpose for me is to study the atmosphere and climate of Venus. We're trying to understand why Venus has worked out so different from the Earth when it really should be much more similar.
And do you think Venus Express is going to answer that question?
Well, I'm sure it'll answer many of them. No single mission can answer all of the questions, but we'll be a lot further forward if everything goes according to plan.
Well, good luck, is all I can say.
Thank you very much.
Anyway, if you want to sound smart about Venus when you're down the pub, here are 5 things you should know about the planet. 1. Venus is the brightest object in the sky apart from the Sun and Moon, and it was one of the first objects to be viewed through a telescope. 2. Previous space missions to Venus have built up a partial picture of the planet beneath the clouds. It's a barren, rocky world with dramatic volcanic features. 3. Venus should be like Earth. Both planets were formed from the same stuff in the same region of space, but Venus has become very hot enough on the surface to melt lead. 4. Some scientists, although not this particular one, believe there could be alien life on Venus.
I personally think that they're nuts.
If it exists, it won't be on the hot surface, it'll be in the clouds, where conditions are much more suitable for life. 5. Venus rotates really, really slowly, so one single day on Venus lasts an astonishing 117 Earth days. Just how bad is our twisted sister planet? Well, the best way to find out would be to go there, but of course that's impossible, so I'm going to do the next best thing. I'm going to have a fantasy trip. And while I'm on my virtual journey, Janet Sumner is going to recreate some of the horrible conditions on Venus for real. Imagine journeying 30 million miles or so for a mini break on our nearest planetary neighbour. As you approach and Venus fills the viewing window, it's an incredible sight. Beautiful, but wild. Hold on to your hats. The winds are ferocious up here. At this level, they circle the planet every 4 days. It's not going to affect me inside the spacecraft too much, but it makes navigation a lot harder. Worse, the high-level clouds are made of sulfuric acid, and it must already be corroding the ship. And the corrosive atmosphere of Venus is the first thing that Janet's going to explore in the lab.
Sulfuric acid is used as battery acid on Earth, and it's nasty stuff. Just watch what it does to this piece of steel. Of course, steel's not used for spacecraft. It's too heavy. Titanium is a spacecraft designer's material of choice. It's light, strong, and resists corrosion. It's not reacting with that acid at all. Titanium was used to make the several Russian Venera spacecraft that landed on Venus in the 1970s. The Venera landers also inspired the shape of Adam's craft.
My spaceship is a sphere, because that's by far the best shape to resist the crushing pressure of the Venusian atmosphere. Any other shape would have weak points that could cave in. I'm not going to have long on the surface. There's no sulfuric acid, that's all up in the clouds, but the atmosphere is mainly carbon dioxide, which I can't breathe. And there's a much worse problem than that, which is the pressure of the atmosphere, the force of it pushing down on me. It's something like 90 times higher than it is on Earth, which is why I've got this special spacesuit adapted to cope with the pressure and stop my body from getting crushed. Wish me luck, folks.
Adam might need more than just luck to survive on the surface. This pressure chamber can go up to Venus surface pressure. Remember, a whopping 90 times that of Earth. I've got 3 objects here. I've got a light bulb, a tennis ball, and Adam's hip flask, because of course you can't be drunk in charge of a spaceship. Okay guys, crank it up! Just like Adam's spacesuit, the test objects are sealed from the air. So, as the chamber pressure increases, there'll be a huge crushing force from the outside in.
Okay, we're going to start pressurising now.
Oh, the ball moved then.
The ball's compressing, isn't it?
Oh, oh yeah, it's sort of compressed in half. I thought it was a shadow.
Check the flask. Oh, I don't know actually.
Is that distorted?
I think that's flattened already.
Is it sort of dipped down in the middle?
Yeah, no, I think we've flattened that at 8 atmospheres.
Amazingly, the flask has gone at just 8 times Earth's normal pressure. I thought it would last the longest because it's made of metal. Let's go back to the light bulb then, because that's the only thing that hasn't gone. We've still got the light bulb. Although the light bulb is made of glass, it's resisting well because the pressure is evenly distributed around it. Whoa!
Oh, right, it went.
It polarised! The light bulb turned to powder at 42 times Earth pressure, but that's still less than half the immense crushing force on Venus' surface. The big surprise for me was the hip flask. That went at only 8 times Earth's surface pressure, and look at it, it's completely flat.
Well, here I am on the surface of Venus. First impressions, it's like a very overcast day on Earth. And it's red. And I guess that's because all the other colours from the sunlight have been filtered out by those thick clouds.
Unfortunately, I don't seem to have lost any weight, because Venus' gravity is roughly the same as Earth's gravity. The strange mirages and optical effects are caused by a combination of the heat and the very dense air.
It also means that the wind has much more effect here because the atmosphere is so thick. It's almost like wading through a stream. But I can't stay long because it's incredibly hot. The hottest domestic oven goes up to about 250 C, and here it's 450. This suit is insulated, but it's not refrigerated because there's nowhere to dump the extra heat. So inside it, I'm cooking.
Heat is a huge problem for missions to Venus. This toy car is made out of zinc alloy, and it's in a furnace that's about to reach Venus surface temperature. Well, it's official. Total meltdown. And that's another reason why Adam's spaceship, like others that have visited Venus before it, is made out of titanium. That has a melting temperature of about 1700 degrees C, so it won't end up like this.
We chose our landing site because it's one of the most interesting areas of Venus.
Over there is the highest mountain on the planet. rises 11 kilometres above the plain. That's 7 miles. Must get a shot of that. Now, if you look, you can see that it's capped with some sort of material, a metal or iron pyrites, fool's gold, which would condense out of the atmosphere at that sort of temperature, on the snow line, in fact. And then down there, most of the surface is made of lava fields. Now there's some really unusual feature just down there, which looks like a river. No one knows how that was formed, but maybe it was just by flowing lava. I think the camera's going. The heat's done for it. No, well, you know what they say. If you can't stand the heat, get out of the Venusian atmosphere.
One of the major problems for missions to Venus is getting the electronic equipment to cope with the heat. Those Russian Venera spacecraft had to be superbly engineered to make it all the way to the surface of Venus and land safely. Even so, the cameras and transmitters only kept working for about an hour before they overheated. In that short time, they managed to send back just these few tantalizing glimpses of the red-hot surface.
Another few seconds and that heat would have been absolutely unbearable, even inside this insulated suit. 100 years ago, some scientists thought that Venus was a hospitable place with lush green jungles under the clouds and perhaps inhabited by friendly Venusians. How wrong they were.
And remember, this astronaut went to Venus by TV technology. The real technology to do it doesn't exist yet.
Venus has been visited by more unmanned spacecraft than any other planet.
The latest is the European Space Agency's Venus Express, and engineers here at the Operations Centre have sent the signal to fire its engines and slow it so it goes into orbit. The engine burn will last 51 minutes, so now we just have to wait and hope.
And if all goes well, the scientists who study Venus should soon be getting some answers to all those burning questions.
The main question is whether there has been an ocean in the early times of that planet.
One of the biggest questions about Venus is why it doesn't have plate tectonics. We want to understand why Venus lost its water.
The main question for me is
why don't we know Venus goes
what's happening
like
in
Venus?
the nature of Venus to understand why and
My main question about Venus is there anything alive floating around in all those clouds?
Everyone's got a different mystery to solve about Venus, but there are two really big questions. The first is,
We still don't really know why Venus evolved into a state that's so much hotter than the Earth.
Venus and Earth must have started out as almost identical twins, but they've grown up to be very different from each other. And one obvious big difference is the surface temperature. Scientists do know that one contribution to the heat on Venus is the greenhouse effect. Some gases in Earth's atmosphere are especially good at absorbing heat, like carbon dioxide, which is also known as CO2, and I can show you how that works. I've got two bottles. One of them is filled with air, and that's at the same temperature as the greenhouse. And into this other one, I'm going to put some carbon dioxide from this fizzy drinks machine. Now that's a bit colder, because it's just come out of the dispenser. I've got a temperature probe to go in each bottle. Stick that in there. And I'm just going to switch on the monitor, set the clock to 12, leave them in the sun, and then we'll come back and see if anything's happened. As the sun warms the bottles, the carbon dioxide is absorbing more heat than the air. After half an hour, the air is at just under 24 degrees, but the carbon dioxide is at nearly 27 degrees. This is the greenhouse effect in a bottle. Multiply it by a whole planet's worth of greenhouse gas, and you get Venus. Venus and Earth started out with carbon dioxide atmospheres, but here the carbon dioxide was absorbed by open oceans. Venus was closer to the sun, so it was hotter, and its oceans boiled away. It was a double whammy. No open water to soak up the carbon dioxide, and an overload of water vapor in the atmosphere. And water vapor is another powerful greenhouse gas, and that caused the temperature to keep on rising. And here's the mystery. Even allowing for the greenhouse effect, Venus is hotter than it should be. And if our current theories can't even explain what happened to our sister planet, how can we possibly be sure about the future of Earth? Since the beginning of the Industrial Revolution 250 years ago, the amount of carbon dioxide in Earth's atmosphere has nearly doubled as we burn fossil fuels and release trapped carbon. Is it possible that one day Earth could go the same way as Venus? The second really big question about Venus is this.
We don't know today if there is active volcanism on Venus.
Active volcanism means live volcanoes. The mystery was uncovered the last time a spacecraft visited Venus. In the early 90s, NASA's Magellan mission used radar to look down through the opaque clouds, and for the first time, scientists saw the whole surface. But there was something missing. Craters. Asteroids and comets hit planets at a fairly constant rate, so one way to work out the age of a body's surface is to count the number of craters. The more craters there are, the older the surface. The scarcity of craters on the Magellan images is evidence that the surface is relatively new, and you don't have to go to Venus to find a similar young surface. This is the holiday island of Lanzarote off the coast of North Africa. Not as hot as Venus, but a landscape formed the same way as Venus's. These are the mountains of fire on the south side of the island. I'm sitting on ground that's less than 300 years old. This whole area was flooded with red-hot volcanic lava, entombing villages and destroying vegetation for as far as the eye can see. There are only a few places here on Earth that have these landscapes, formed by lava flows.
This is a map that's got different areas of the Earth's surface, colour-coded according to age. Now here's the British Isles with a wide range of surface ages. Here's India, and all this yellow stuff, 65 million years ago, that vast area was flooded by lava flows. Come across to the Canary Islands, a large part of Lanzarote was flooded by lava flows nearly 300 years ago. Venus is very, very different.
The surface of Venus was formed about 500 million years ago, young in terms of the planet's age. And the whole surface looks like it was all formed at the same time. But here's the mystery. There's no sign of any active volcanoes on Venus. One explanation is that the heat builds up under the surface, then molten rock bursts out all over the planet, all in one go. Well, here's my cratered surface of Venus, and I've scored a fault line into it. These are typical landscape features of Venus. And I'm going to heat it up, and we'll see what happens. The hot wax, representing molten rock under the surface of Venus, finds weak points, then breaks out and floods the entire planet, wiping out the craters and sealing in the heat once again. So why does this happen all over Venus, but in just a few places on Earth?
We think the reason Venus behaves differently is that it's lost its water. The Earth's rigid outer shell, the plates can move around. Their bases are lubricated. That doesn't happen on Venus. So a lot of heat is building up. Venus bottles it up and then it lets it all rip in one go.
The second possible explanation is that resurfacing goes on gently all the time, with lava constantly finding its way to the surface and seeping out. So far, there's no evidence that this happens, but Venus Express will look for volcanic gases in the atmosphere. If it finds them, that'll confirm that Venus is still active and that it is constantly being resurfaced. If it doesn't find them, well, that could be even more interesting.
Sometime in the future, we don't know when, the whole of Venus will be resurfaced once again in a global orgy of resurfacing. It may be next week, it may be next year, it might not be for 100 million years.
Before they can get answers to some of those questions, they're going to have to get Venus Express successfully into orbit around the planet.
The spacecraft has just disappeared behind Venus, so it's out of radio contact. This is an agonizing 10 minutes for the team.
It's curious, really, that we know so little about Venus because it's one of the brightest objects in the sky. But at least it's easy to observe even with a simple telescope. And just to prove that's the case, we asked an amateur astronomer to have a go. Myleene Klass is better known as a star than as a stargazer. And her hectic life in London leaves little time for observing.
Good morning and thank you for your company. I'm Myleene Klass. Coming up, I've got a fantastic chill-out choice, but first, it's Tchaikovsky.
She's been involved in music since she was little, but she's also passionate about astronomy ever since her dad, a sea captain, showed her the North Star when she was 8 and gave her a telescope for Christmas.
The only problem with viewing Venus at this time of the year is the very early start. But here we are up on the rooftop, and over there is southeast, so hopefully we should get to see something.
The very first person to see Venus through a telescope was Galileo, about 400 years ago. He noticed that its shape and size changed from week to week.
Venus looks different from time to time, as well as looking smaller and bigger. Sometimes it can look like a crescent, a semicircle, and sometimes almost a full circle.
When Galileo first observed it, he realized what it meant immediately. Venus had to be a globe, orbiting the sun and reflecting the light. It gets bigger or smaller as it moves closer or further away in its orbit. Galileo's ideas were very controversial at the time. They meant that the sun must be at the center of the solar system, whereas the Catholic Church insisted that the Earth was at the center. So Galileo ended up under house arrest, at least partly because of his Venus observations.
This telescope is pretty similar to the one Galileo would have had. It's a refracting telescope, 2 lenses, but this one is more sophisticated. It has a finder scope, which helps you line things up.
Because Venus is so featureless through the telescope, many early observers let their imaginations run wild. That's why they saw things that simply weren't there. Mountaintops, continents, even polar ice caps. It wasn't too big a step to imagine forests, lakes, and bathing Venusian maidens. Even Percival Lowell, the American astronomer who thought he saw canals on Mars, also imagined he saw evidence of canals on Venus, and mapped them in some detail. And many people spotted a faint light from the dark side of Venus, the so-called ashen glow. Explanations range from luminescent oceans to a glimpse of city lights under the clouds, though it was most likely an optical illusion.
Fantastic. There it is. Worth getting up in the morning for.
Now, Venus Express is about to reappear from behind the planet and remake that contact with Earth. It's very tense here in the control room as they wait for the signal. I'm not sure what's happening, but it doesn't look too good.
The problem was that it took much longer than expected for the tracking stations on Earth to find the radio signal again. A hot-stopping 2 minutes.
That means that the 7 science instruments on the spacecraft can now be switched on and begin the 2-year process of collecting data and images and sending them back. one of the most surprising things they'll be looking for is signs of life, even on this most inhospitable planet.
Professor Charles Cockell is investigating the possibility of life on Venus by examining microbes that live in extreme acid conditions on Earth.
They really tell us about how life can conquer almost every habitat on Earth. What has this got to do with Venus? Well, the clouds of Venus are very acid, and there's been a lot of speculation that they might be good places for microbes to survive. There's a band within the atmosphere of Venus that actually has temperatures between 0 degrees and about 120, within the temperature range for life. And we know that there's small amounts of liquid water in those clouds, and the pressure isn't too high either.
But there's one major snag. The microbes in Cockell's lab live in 1% sulfuric acid. But in the clouds of Venus, the acid concentration is a staggering 98%. Even so, some people think they might still harbour life.
They speculate that there might be organisms that have evolved to be able to deal with 98% sulfuric acid. I personally think that they're nuts, because I think that the clouds of Venus are much too extreme for life.
Another possibility is that life evolved in the past when conditions were more favourable and lingers on in a few small patches.
I've no doubt that in some distant time in the future there will be samples from the atmosphere of Venus, and some crazy microbiologist will be in a lab trying to find life in these samples.
So, Fred, what do you think? Could there be life on Venus?
Well, I think there could be life almost anywhere. We haven't really written the book on life in the universe yet. It's just a lot of blank pages. And we don't really know how adaptable life is, whether it can adapt to really extreme conditions. We don't know how common it is. We don't know whether life is a piece of chemistry that crops up all over the place like a disease, or whether it's something very unique and rare. It's hard to see how it would have arisen on Venus in the first place. It certainly can't be ruled out. But if you asked me to stake my mortgage on it, I would say no.
Thanks, Fred. Well, one step on the way to answering all those mysteries about Venus was getting Venus Express safely into orbit. So, Dmitri, are you happy?
Yeah, very happy now, yes. I think that we all are happy. You see from the faces, it's written here.
Yeah. How was it in the control room?
Yeah, wonderful. I think, the people were very quiet, very confident in what's happening, and really they will follow each step. It was, I would say, like in a textbook.
Everything worked absolutely beautifully as it was intended, and we are in orbit.
You're a happy man.
I'm a happy man.
Okay.
All my colleagues are happy.
I can see that.
Great job.
The mission begins here.
That's right. So, from a bunch of very happy scientists and engineers here at ESOC, that's all from Stardate. Goodbye! For a free copy of this poster about Venus and Venus Express, and for details of Open University courses and TV programs, call 0870 900 0312 or visit open2.net.